Hello students, Professor Nugent here. In this video we're going to discuss using a lagged dependent variable as a proxy. This is an imperfect solution when we don't know what to use as a proxy variable. In the last video we looked at an example where we had an omitted variable that was ability, and we didn't have data on ability, but we probably could have used something like IQ as a proxy variable. Sometimes we just don't have a good idea of what we can use as a proxy variable. So we can use the lag dependent variable to, for instance, control for difficult to measure historical factors that cause current differences in the dependent variable. A good example of this would be an inertia effect. An example of an inertia effect is that we see some areas that have historically high crime rates, and there are many factors that are unobserved to econometricians that contribute to current and past high crime rates. So cities with high historical crime rates may spend more on crime prevention, and there are unobserved factors that affect crime that are probably correlated with expenditures on crime prevention and unemployment. We're thinking about things like budgets, police behavior, the opportunity costs of expenditures on crime prevention. So what are we spending on crime prevention that we could be spending on other things like social welfare programs? So we can control for all of this stuff by including previous period crime in an equation predicting current crime as a function of unemployment and expenditures on crime prevention. So we have an equation, crime is equal to beta naught plus beta 1 times unemployment plus beta 2 times expenditures plus beta 3 crime from the previous period plus u. So to do this, we would require crime from this year and crime from last year, unemployment this year, expenditures this year. And again, we're doing this because some areas have historically seen high crime rates. There are many factors that are unobserved to econometricians that contribute to current and past high crime rates. Cities with high historical crime rates may spend more on crime prevention. And there are unobserved factors that affect crime that are probably correlated with expenditures on crime prevention and unemployment. So we want to be able to bring this in so that we can control for these unobserved factors and help with the omitted variable bias problem so that we can get unbiased and consistent estimates of beta 1 and beta 2. Now when we do this and interpret beta 1 and beta 2, then we can think about, for two cities that have the same previous crime rate and the same unemployment, what is the effect of a difference in expenditures on crime prevention? Okay, so that is the interpretation of beta 2. We can also think about the interpretation of beta 1. For two cities that have the same previous crime rate, think about beta 1, the same previous crime rate and the same current police expenditures, what is the effect of a difference in unemployment? All right, so that is how we can control for previous crime expenditures and then hope to have unbiased and consistent estimates of beta 1 and beta 2 so that we can make ceteris paribus conclusions. So this is using a lag-dependent variable as a proxy for the unobserved stuff that affects unemployment and expenditures, past and current, that is correlated with this stuff, that is important for crime. So if we didn't bring this stuff into the equation, we would get omitted variable bias. By using a lag-dependent variable, we bring that unobserved stuff into the equation, we control for it, and we mitigate that omitted variable bias problem a little bit better than we would if we just left it completely out of the equation. That's it for using lagged dependent variable as a proxy. Stay tuned to the next video. We'll discuss the characteristics of OLS under measurement error.